Megan. So let's take a look at this next one. It says adding and subtracting fractions depends on finding a common denominator, right? We can't add or subtract fractions if they have different denominators. Here we've got a 4, here we've got a 9. They're different. We can't add them because a 4th and a 9th are very different sizes. So they have to be the same size in order to add or subtract them. The least common denominator is the least common multiple of the denominators that occur in the computation. Find the least common denominators and compute the following additions and subtractions. So let's start with 3/4. Whoops, I guess I haven't selected my brush yet. Let me grab that. Excuse me. Okay, I'm going to do this in red. So we've got 3/4 plus 1/9. And let's just talk about why we can't just add across like this. So we can't go 3 plus 1 equals 4, and 4 plus 9 equals 13. Okay, 3/4 plus 1/9 equals 4/13. Stop and think about that for just a second and why that can't be. Right, 3/4. If I have 3/4 of like a circle, okay, here's fourths. Let me grab a different color to color this in. If I take 3 of them, that's almost the entire circle, right? That's a majority of the circle. 4/13 isn't even half. Right? If I had a circle and I cut it into 13 pieces, let's see, I've got 4, 5, 6, 7, 8, and they'd have to be equal size pieces. This is going to be a little off. 9, 10, 11, 12, 13. So these aren't exactly equal size pieces. But if I colored in 4 of them, 1, 2, 3, 4, that's not even half of my circle. So to start with 3/4 and then add something to it and wind up with 4/13, which is itself much smaller than what I've started with, that 3/4, that doesn't even make sense. So if what this problem is saying is that we can't add here, we can't just add because the denominators are different. We've got a 4 and we've got a 9. So we cannot just simply add straight across, right? We've just proven that. When we added straight across, we got something smaller than what we started with, and that doesn't make sense for an addition. Okay, so that's the first piece I want to make sure you understand, is that we cannot simply just add that. And so we need a method for figuring out, how do I add this then, right? If I've got 3/4 and I want to add 1/9 to it, how do I figure that out, right? I can't just add straight across because the 4 and the 9, the denominators are different. So I need to make them the same size somehow. And the strategy for doing that is by finding the least common denominator, or another way to say that is the least common multiple. And that's what we learned about in class last week. So we have to somehow make the denominators the same, okay? Because I can add fourths and fourths, right? If I have, let's just pretend, if I have 3/4 and I add 1/4 to it, right? So if I've got 3 of these colored in and I add 1 more, well, then I can just add, right? 3 plus 1 is 4. That leaves me with 4/4. The denominator would stay the same, right? If I took this 1 little fourth and I just added it to my 3/4, then I'd wind up with 1 whole. So as long as the denominators are the same, I can just add the numerators straight across. My denominator stays what it was, and I can get an answer. And so our whole goal for this is to find that common denominator, that 4, I can change 3/4 and 1/9 to have the same denominator so that I can simply add them. So how am I going to find that common denominator? I'm going to find the least common multiple of 4 and 9. And so there were a few different strategies that we talked about for finding the least common multiple. And because these numbers are so small, right? It's not like we're dealing with numbers in the hundreds or thousands. We can use the very first method we talked about, where we basically just skip count and we find the number that both have in common. So I'm going to start by finding the multiples of 4. And so we denote that by writing M for multiples, and we write this little subscript 4. So my first denominator is a 4. Let me find all the multiples of 4. How do I do that? I just skip count. 4, 8, 12, 16, 20, 24, 28. Notice I'm just skip counting by 12s, 32, 36, 40, 44, and I'm going to list a bunch of them. Okay, and I'm just going to stop there. So now I'm going to pick a different color for 1/9. I'm going to go with blue just to keep this organized for us. So now I've got my 1/9. 9 is my denominator. So now I need all the multiples of 9. So again, I'm just going to skip count by 9s. 9, 18, 27, 36, 45, 54, blah, 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 blah. And so the next step is, okay, I look at both of these lists and I see which numbers, which multiples both of these lists have in common. So what multiples of 4 and 9 are the same, okay? Which multiples do 4 and 9 share? So I'm just going to go back to my black. Do they both share a 4? No. Do they both share an 8? No. Do they both share a 12? No. A 16? Nope. A 20? No. 24? Nope. 28? Nope. 32? Nope. 36. Here's one. They both share a 36. They don't share a 40 or a 44. Okay. But the cool thing about this is because it's the least common multiple, as soon as I found the first multiple that they have in common, I'm done because I'm looking for the least common multiple. Least means smallest. This is the smallest multiple that both numbers share, right? 36 is a multiple of 4, meaning if I skip counted by 4s, I would land on 36. And 36 is also a multiple of 9, meaning if I skip counted by 9s, I would land on 36. So I have found the least common multiple, the smallest multiple that they both have in common. It's 36. So now I can move on to the next part because it says compute the following additions and subtractions. So now I actually have to compute 3/4 plus 1/9. Okay, so I'm just going to scroll down here. I have to do 3/4 plus 1/9. And the way that I do that is by using that least common multiple, right? We figured out the LCM, the least common multiple is 36, which means I have to turn both of my denominators into 36. So I'm going to start with 3/4. And I need to say to myself, okay, what number do I multiply 4 by to get to 36, right? And so if I count by 4s, 4, 8, 12, 16, 20, 24, 28, 32, 36, I need to multiply 4 by 9 to get there. So I know I need to multiply by 9. Whatever I do to the denominator, I have to do to the numerator in order to keep the fractions equivalent. So I know that 4 times 9 is 36. 3 times 9 is 27. So 3/4 is exactly the same as 27/36. It's exactly the same fraction, okay? If I were to reduce this to its simplest form, I would get 3/4. These are mathematically equivalent. The difference is now I've got that 36 as my denominator, which is exactly what I wanted. So my 3/4 became 27/36. So I've changed one of my fractions. Now I need to change the 1/9. I'm going to do exactly the same thing. I know I want 36 in my denominator. So I say to myself, what do I multiply 9 by to get to 36? 9, 18, 27, 36. I need to multiply by 4. Okay, and whatever I do down here to the denominator, I also need to do to the numerator to make sure my fractions stay equivalent. 1 times 4 is 4, and of course 9 times 4 is 36. So now I know 1/9 and 4/36 are equivalent fractions. If I were to reduce 4/36, in fact, I would get 1/9. But the beauty is now I've got that 36 in my denominator, which is exactly what I wanted. So my 1/9 became 4/36. And now I've got an expression that I can actually compute, right? I could not do 3/4 plus 1/9. I could not compute that because the denominators were different. My goal was to make the denominators the same, and that's exactly what I've done. They both have a denominator of 36. So now I can compute this addition. I can do 27/36 plus 4/36, right? I know my denominator is going to be 36. When we add or subtract fractions, the denominator just simply stays. And then I just add the numerators. 27 plus 4 is 31, okay? So my answer here is 31/36, and I would need to say to myself, can I reduce this? Because I think it asked for the fraction in simplest form. So let me see. It says simplify your answer and type a whole number or fraction. So I need to say, can I reduce this at all? Meaning, do 31 and 36 have any common factors? I do not believe that they do. I believe this is in simplest form because I believe 31 is prime. So my answer would be 31/36, which is exactly what I would type into this box right here. Okay, so your goal for this is to look at the denominators and realize, oh, they're different. I can't simply just add. I need to find the least common multiple, so I need to skip count by both of these denominators. Figure out what the smallest multiple they have in common is, change my original fractions to my new fractions so that they have the same denominator, and then perform the addition or subtraction, okay, just like we did here. So if you need to, when you go on to parts B, C, and D, just go back and start this video from the beginning and follow my process. Let me know if you have any questions. Thanks, Megan. Bye.